Okay guys, so I lost some of my video, so this is going to be part 2 of the lab. So we just did part 1, and now this is going to be part 2. So in part 2, we're going to do another single replacement reaction in which we take hydrochloric acid, okay, and we're going to drop in some pieces of zinc metal, okay, so zinc metal and hydrochloric acid. And when we do this, we're going to do a single replacement reaction in which zinc and HCl, or the H, are going to swap places. So we're going to be left with hydrogen gas and zinc chloride. Now, we'll be able to see the zinc chloride changing as we watch the solution. But how do we once again know that we've gotten the gas? Well, we're going to use another tube, an empty test tube, and we are going to invert that on top and collect the gas. And then once we've collected that hydrogen gas, we're going to light a wood splint and put it underneath the mouth and react hydrogen with oxygen, which is the next reaction in this experiment. And we're going to react hydrogen with oxygen and make water. So there's 2 reactions going on in this one whole process. So we're going to, like I said, we're going to add these pieces of zinc in here. And as you can see, it bubbling. Okay, so now you see the gas coming out, so we don't want to lose all of our gas. So I'm going to go ahead and put my other test tube on top of this and collect as much gas as I possibly can. And you can kind of see it, right, traveling up into the tube. All right, and I'm going to collect as much as I can for about 30 seconds here. I've got a lot of it, you can tell, because some of it's coming out. So I'm going to collect this, and then I'm going to light it on fire, and you're going to hear a noise. You're going to hear a popping noise, okay? So I'm going to go ahead and light my wood splint. Okay? I'm going to go ahead and stick this in here. Slide this over. And you heard that noise, right? Now, if you didn't hear it, I'm going to do something where you might be able to hear it a little better if I do it here. All right? So that's what it's doing. So that's making water. So you hear that popping noise one more time. Okay? That noise is the hydrogen mixing with the oxygen and creating water. Okay? So that was another single replacement reaction. Now I don't need my fire anymore, so I'm going to go ahead and turn that off. Now we're going to do some double replacement reactions, okay? So you'll notice that you have 3 different boxes. So we're going to do 3 different double replacement reactions. Remember, in a double replacement reaction, the metal ion of each compound switches places to the other side, okay? So the first experiment that we're going to do is we're going to have sodium phosphate, and we're going to mix it with zinc acetate. After we do that, it's going to create a precipitate where zinc phosphate is formed as a precipitate, and then you'll have sodium acetate left as solution, okay? So I'm going to start off by adding my sodium phosphate in a, this is not a clean test tube, try this one, in a clean test tube, and I'm going to add about 2 to 3 mils of sodium phosphate in here, okay? Now, once I add that, now I'm going to add some drops of zinc acetate. So I'm going to bring this up to the camera so you can see, okay? So you can see this is clear solution. This is my sodium phosphate. Now I'm going to add a clear solution of zinc acetate. So watch what happens. And as I keep adding, I'm going to form a solid here. Can y'all see that? You'll see it kind of almost looks like a snowstorm, right? So I made this thick solid, and that's my zinc phosphate that I just formed. So double displacement reaction, sodium phosphate, zinc acetate produces a solid zinc phosphate solution with sodium acetate still in solution, okay? So that's the first of my double replacement reactions. Now I'm going to do another double replacement reaction in which I mix sodium phosphate again, so same solution, sodium phosphate, okay? And I'm going to mix that with another substance of cobalt nitrate, okay? So that's going to be my next experiment for my double replacement. Now, so my sodium phosphate, my clear solution here, I'm going to mix with a pink solution of cobalt nitrate. When I mix them, I'm going to create cobalt phosphate and sodium nitrate. Okay, so sodium nitrate will stay in solution and cobalt phosphate will be my precipitate. So now I'm going to add that in there. And as you can see, can y'all see that? Can you see? So we have a purple solid, very pretty in color, okay? And that's my cobalt phosphate right there, okay? So that's what forms in that reaction, all right? And last, I'm going to do my final double replacement reaction in which I mix cobalt nitrate, so 2 to 3 mils of cobalt nitrate, and I'm going to mix that with sodium hydroxide, okay? So when I do this, I'm going to form a precipitate of cobalt hydroxide and sodium nitrate again. So the cobalt nitrate is pink in color. I have a clear solution of sodium hydroxide. So now when I add this, I get a beautiful blue color, okay? As you can see, a beautiful blue color, and this is my cobalt hydroxide. And actually, if you let it sit for a while, it'll actually separate almost into 2 different types of solids, okay? So that's another double replacement reaction. And now you've seen all the reactions for our lab. I gotta find a spot to put that. So you can go ahead and do your post lab. There's not a whole lot of write up to your post lab. You're just going to be doing balancing the equations, so you have to write out your equations in the boxes. So these boxes right here. And then if you've already done the appearance and what it looks like before, during, and after the experiment, you won't have to do this very last page. This is just a summary of everything else. So some people chose to use the table, and some people chose to just write it out as they were going along. Okay, so if you've done the part where you're writing it out as it's going along, that's all you have to turn in. You don't have to do that very last page. You do, however, have to balance the equations. Okay, so I hope you enjoyed the lab. Like I said, it's a lot more fun in person, but at least you got a little bit of taste of what we did in the types of chemical reactions lab. Okay, have a good day.